hydrogen will be also used in production of fat where the oil is allowed to react with hydrogen. For the group 1 element, it has a general formula MH, where M stands for metal and H stands for hydrogen. There are 3 types of the hydrates will be there: ionic hydrates and covalent hydrate, and last one is a metallic hydrate. When dihydrogen reacting with H block element, they forms a ionic hydrate. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called hydrogen. Under that, we have studied about the position of hydrogen in the periodic table, and also we have learned about the resemblance of the hydrogen with the alkali metal, and also we have discussed about the resemblance of the hydrogen with halogen, and also we have discussed about the occurrence of hydrogen in the nature, and also we have talked about the preparation of hydrogen in the form of dihydrogen. Today, let us discuss the physical properties of hydrogen, and we are going to discuss the chemical properties of hydrogen, and lastly, we are going to discuss about the uses of dihydrogen, and we are also going to discuss about the hydrate. So, firstly, I will go with the physical properties of the hydrogen. So, when we talk about the physical properties of the hydrogen gas is a colorless, odorless and a tasteless gas. So, it is colorless, odorless and a tasteless gas. Usually, it has a density which is lower than the other chemical element which is there in our periodic table. The example is, you can see that this is having a density around 0.089 gram. So, which is very much lower as it is compared with the rest of the elements in our periodic table. And hydrogen can changes from gas to the liquid at the temperature around minus 252.77 degree Celsius, and it can solidify at a temperature around minus 259.2 degree Celsius. So, it can changes its state from the gases to liquid than from liquid to gases. Okay. Simply by altering the temperature, we can change the state of the gases. And remember, this hydrogen gas are insoluble in water and alcohol and with the other common solvents. So, these are the 3 important physical properties of the hydrogen. Now, let us see the chemical properties. In this, we are going to understand how does the dihydrogen is reacting with the halogen or with the other element. Let's see now. First, I will go with the reaction of hydrogen with halogen. Okay. Dihydrogen combines with the halogen to form a hydrogen halide, and the reactivity of the halogen towards a dihydrogen decreases in this order. That will be follows the fluorine, chlorine, bromine and iodine, which is in a decreasing order. Now, let us see with the reaction now. When a dihydrogen combines with fluorine in the presence of dark sunlight, you know, it gives to the hydrogen fluoride, so which is a hydrogen halide. Similarly, when a hydrogen combines with the chlorine in presence of diffused sunlight, it forms what? 2HCl. Similarly, when hydrogen combines with the bromine and it forms what? 2HBr, that is hydrogen bromide. Similarly, when dihydrogen combines with iodine, it forms what? Hydrogen iodide. You can see that the hydrogen, when it is react with the halogen, it forms what? hydrogen halide will be formed, and you can see that all these elements which is in the decreasing order of their reactivity with the hydrogen. Next is reaction with the dioxygen. When hydrogen reacts with dioxygen, it will form what? Water. And remember, this reaction is exothermic in nature. So, dihydrogen reacts with oxygen in presence of any catalyst. Upon heating, it gives rise to what? Water. And remember, this is an exothermic reaction because the excess of heat will be produced during this reaction, and which is having enthalpy around minus 285.9 kilojoules per mole. This is how our dihydrogen reacting with the halogen forming a hydrogen halide. When it is reacting with the dioxygen, it forms what? Water. Next is reaction with dinitrogen. When hydrogen reacting with dinitrogen in presence of iron as a catalyst around 673 Kelvin under the pressure around 200 atm, it will form ammonia, and this will be another important process which is used in manufacturing of ammonia. Hence this process, which is also known as Haber's processes, which is also known as what? Haber processes. Okay. So, I will go with the reaction now. You can see that dihydrogen reacting with the nitrogen in presence of iron as a catalyst at very high temperature around 773 Kelvin at a high pressure around 200 atm. It will forms what? It will combines with the nitrogen. It forms ammonia. This is a process which we are learning in your first PUC for the preparation of ammonia, and this process which is also known as Haber's processes. Next is reaction with the metals. When dihydrogen combines with the many metals at very high temperature, it will yield a metal hydrate. It yield what? Metal hydrate. So, example, I have written a general reaction where dihydrogen reacting with the metal, I have used the M as a metal here. It will form what? Metal hydrate. You can take the example of sodium here, which is a group 1 element. When dihydrogen reacting with the sodium metal, it forms what? Sodium hydrate. Okay. Similarly, when dihydrogen reacting with the magnesium, which is a group 2 elements, it forms what? Magnesium hydrate. This is how when our dihydrogen reacting with any metal, it forms what? Metal hydrate. More about the metal hydrate, I will explain you in the next slide. Okay. So, hope you all understood with how our dihydrogen reacting with the dinitrogen to form ammonia, and how does it also reacting with other metals to form a metal hydrate. Next is reaction with metal ion and with the metal oxides. Dihydrogen gas can reduces one metal ion in aqueous solution and oxides of the metal into the corresponding metals. Here you can see that dihydrogen, when it is reacting with the metal, that is a metal ion. So, you can see that I have used the palladium ion here, which is a metal ion. When dihydrogen reacting with metal ion, it forms what? It reduces the metal and get converted into H plus ion. Okay. Similarly, when dihydrogen reacting with metal oxide, reacting with what? Metal oxide, it forms what? Xm, that is a metal with the formation of water. This is how when dihydrogen reacting with metal ion, it reduces the metal ions into metal with the formation of H plus ion. When it is reacting with Metal oxide, it reduces the metal oxide into metal which exists in a solid state with the formation of water molecule. This is how our dihydrogen can react differently with the metal oxide as well as with a metal ion. Next is reaction with organic compound. Dihydrogen can react with many organic compounds in presence of catalyst to give a hydrogenated product. So for this, I have used the one example by taking hydrogenation of vegetable oil in presence of nickel as a catalyst. Here, I have considered the oil which is allowed to react with dihydrogen in presence of nickel as a catalyst. It forms what? Hydrogenated product. So, at very high temperature around 180 degrees Celsius, the oils will get converted into fat. So, this is how our dihydrogen can react with organic compound to form a hydrogenated product. Next is, we have one more reaction. The hydroformylation of alkene gives aldehyde which is further undergo reduction to give a alcohol. Here you can see that I have used the dihydrogen which is allowed to react with carbon monoxide as well as with the alkene. What will happen? So, when dihydrogen react with the carbon monoxide, so which breaks a bond between the two carbon atom and results in a formation of aldehyde. You can see that this is a aldehyde group will be there, which is upon further reaction with dihydrogen, it gives what? Alcohol. It gives what? Alcohol. You can see that the OH group will be there. This is how hydroformylation of alkene will be done. By using dihydrogen, it gives rise to the aldehyde, which is upon further reaction with the dihydrogen, it gives rise to the alcohol. So, this is a alcohols. So, hope you all understood with this reaction. Next is uses of dihydrogen. So, till now we have learned about the physical property and the chemical properties of the dihydrogen. Now, let us see what are the uses of dihydrogen. Okay. It is used in production of ammonia by Haber's processes. Already I have explained that when dihydrogen reacting with dinitrogen, it forms what? Ammonia. Ammonia. So, this process will be used in production of ammonia. Hence, this process which is known as Haber's processes. And hydrogen is commonly used in power station as a coolant for the generators and used in manufacturing of vanaspati. So, we know that vanaspati is a fat. We know that how hydrogen can react with the oil to form a hydrogenated product. That is why hydrogen will be also used in production of fat where the oil is allowed to react with hydrogen by hydrogenation of vegetable oil. The largest application of hydrogen is for processing of fossil fuel. So, during the processing of fossil fuel, we also use the hydrogen in excess quantity. And hydrogen will be also used in shielding gas and welding method such as dihydrogen welding, and it is also used as rocket fuel in the space research. Let's continue with the remaining uses. Hydrogen can also be used in manufacturing of methanol. Already I have explained that how does the hydrogen can react with carbon monoxide as well as with the alkene to form a aldehyde, which is upon further reaction with dihydrogen, it gives rise to the alcohol. You can see that carbon monoxide reacting with the hydrogen to form a methanol, which is an alcohol. Okay. The stars can also use this hydrogen as a fuel, which produces the energy for the stars. And direct reaction of dihydrogen with a chlorine will be used in production of hydrogen chloride. When dihydrogen reacting with chlorine, it gives to the HCl, that is hydrochloric acid. During the production of this hydrochloric acid also, we use a dihydrogen. And dihydrogen, which is also used in manufacturing of metal hydrate. Already I have explained that when dihydrogen reacting with the metal, it forms what? Metal hydrate. It forms what? Metal hydrate. This is how when our dihydrogen reacting with the metal, it forms a metal hydrate. And in metallurgical process, it is used to reduce the heavy metal oxide to form a metal. So already we have understood this part also, where our metal oxide can easily get reduces into metal, as well as the metal ions can also be get reduced to metal by using dihydrogen. Is it right? The best example I can write is dihydrogen reacting with palladium metal ion. It reduces the metal with the formation of H plus ion. Is it right? Similarly, when metal oxide is there, if metal oxide is there, when it is reacting with the dihydrogen, it forms what? Metal with the formation of water molecule. So, during this processes also, we can use this dihydrogen for reduction of metal oxide into metal. And we have a last application, that is hydrogen will be used as a fuel in the space rocket as well as in the guided missiles. So, these are the important uses of dihydrogen and the physical and chemical property. Now, let us see more about the hydrates. Okay. The binary compounds of hydrogens are known as hydrate. What does it binary indicates? Binary means 2. Okay. The binary compounds of hydrogen. For example, you can say B2H6. Is it right? Which is a binary product. Generally, we write this as BH3. If it is a binary product, we write it as B2H6. Okay. Similarly, you can take one more example, magnesium hydrate. So, which is a binary form of hydrogen, which is said to be hydrate. Okay. Here, E is a symbol of an element. Then, the hydrate can be expressed as EHX. So, this is a general formula to represent metal hydrate. What is the E here? E stand for the metal and H stand for the dihydrogen. So, example is MgH2 and EMHN, which will be, that is the example of binary hydrate. Okay. And again, once we have understood about the hydrate, we need to know about their types. So, there are 3 types of the hydrates will be there: ionic hydrates and covalent hydrate, and last one is a metallic hydrate. Remember, ionic hydrate can also be known as saline hydrate, whereas covalent hydrate, which is also known as molecular hydrate, whereas metallic hydrate, which is also known as non-stoichiometry or interstitial hydrate. So, what is an hydrate? Remember, the binary form of hydrogen. Binary means what? H2. Is it right? The binary form of hydrogen, which is known as hydrate. The best example is magnesium reacting with the dihydrogen. It forms what? Magnesium hydrate. So, this is the example for hydrates, where the binary form of hydrogen is there, hence it is known as metal hydrate. So, there are of 3 types: ionic, covalent and interstitial hydrate. First, I will go with the ionic hydrate. These are the stoichiometric compounds of dihydrogen formed with most of the S block element. So, when dihydrogen reacting with group 1 and group 2 element which forms the ionic hydrate. Okay, which are the S block elements in the sense? Group 1, that is alkali metals. Similarly, group 2, that is alkaline earth metals. These two together known as S block. Correct? When dihydrogen reacting with alkali metals, you know, the best example is sodium reacting with dihydrogen, it forms what? Sodium hydrate. Okay? Similarly, when lithium reacting with dihydrogen, it forms what? Lithium hydrate. Similarly, when I go with the alkaline earth metal, I will take with the magnesium. When it is reacting with the dihydrogen, it forms what? Magnesium hydrate. So, when it is reacting with alkali metals and alkaline earth metals, their formation of hydrate is also get different. Is it right? Yes. The elements of group 1 and group 2, except lithium and beryllium and magnesium, they forms a ionic hydrate, and ionic hydrates are also known as what? Saline hydrate, because of the salt-like hydrate formation, because of their property which are identical to the salt, hence it is known as saline hydrate. So, in ionic hydrate, hydrogen exists as H- for the hydrates of group 1. The general formula is MH, that is the example of sodium hydrate and lithium hydrate. M stands for, it may be sodium, potassium, rubidium, as well as with the cesium and francium. So, example are sodium hydrate, potassium hydrate, rubidium hydrate. You can write with the cesium hydrate and francium hydrate also. Where dihydrogen, when it is reacting with group 1 element, they have a general formula of MX. Okay. Similarly, for the hydrates of group 2, they have a general formula of MH2. Here you can see that when magnesium reacting with the dihydrogen, they forms a magnesium hydrate. So, I have written H2. But whereas in the alkali metals, I have written NaH. So, here the metal hydrate will be having the general formula of MH, whereas in the alkaline earth metal, it will be having the general formula of MX2. Example, the calcium, strontium and barium will be exist in CaH2, strontium hydrate and barium hydrate, and calcium hydrate are the examples for the ionic hydrate. Remember, when dihydrogen reacting with S block element, they forms a ionic hydrate. So, remember, for the group 1 element, it has a general formula of MH, where M stands for metal and H stands for hydrogen. Hence, it is named as metal hydrate. Whereas, alkaline earth metal, they have a general formula of MH2, where M stands for metal. It may be calcium, magnesium or strontium or with the barium. Now, let us see with the covalent hydrate, or it is also known as a molecular hydrate. The elements of the group 13 to 17 are forms of covalent hydrate. We know that the group 13 to 17 in the periodic table, which is known as P block element. Is it right? Group 13 to 17, they are known as P block elements. So, when it is reacting with the dihydrogen, it forms what? Covalent hydrate. So, they possess a covalent bond with their structure. Example, BH3, AlH3, CH4, NH3, H2S, water or with a HCl. But remember, we have the hydrates of group 13 and 14 are usually neutral in nature. So, when dihydrogen reacting with group 13 elements, group 13 element. So their hydrates will be neutral in nature. Their hydrates will be neutral. Whereas the hydrates of group 15, they are basic in nature. Similarly, group 16 and 17, they are known as acidic in nature. So these are the special characteristics of the hydrate when it is reacting with P block element. From the group 13 to 17, we known as P block elements. I have listed out the noble gases here because I am not considered the noble gas to reacting with the hydrogen, because we know that noble gases will not react with any other element. That is why I have left it out the group 18 till group 17 I have considered as a P block element. The molecular hydrates are further classified into three types. They are electron deficient, electron precise and electron rich hydrate. So why we have classed according to the relative number of electrons which are present during the bond formation. That is why this covalent hydrates are further classified into three types, that is electron deficient, electron precise and electron rich hydrate. First I will go for electron deficient hydrate. So the name itself indicates that these are the hydrate which are having electron deficiency. That is why it always looks for the acceptance of the electron. Okay. So they have very less number of electron and them required for writing the conventional Lewis structure. All the elements of group 13 which forms an electron deficient hydrate. Example is diborane, which forms a Lewis acid because it is an electron acceptor. Why it is known as electron acceptor? Because it is having the electron deficiency in their writing their conventional dot structure. That is why they are known as electron acceptor. If somebody has given the electron to them, then it will accept the electron because of its deficiency. Okay. Then comes to the electron precise hydrate. The name itself indicates that electron precise. So such kinds of hydrate will have a precise quantity of electron. Already it has a how much the electron which is required for the bond formation it will have, and it will form a hydrate. So the electron precise hydrate have a required number of electron to write their conventional Lewis structure. All the elements of group 14 which forms a electron precise structures or hydrate. Example is CH4. So in CH4 we know that there are 4 hydrogen atom will be there and 4 hydrogen atom which donate 1 electron to the carbon atom, and carbon itself will share 1 electron with the hydrogen atom and forming a covalent bond. Hence it is known as electron precise hydrate. Next is electron rich hydrate. So those hydrate which are having the excess of electron which can readily give rise to the electron for other metal to form a covalent bond. Such hydrates are known as electron rich hydrates. They have a excess of electron which is present as a lone pair of electron. Example, you can see that in water molecule, oxygen has 2 lone pair of electron. Similarly, in ammonia, if you write, nitrogen has 1 lone pair of electron. So these are the electron which are excess in their nature in that particular metal atom. Hence such electrons are known as lone pair of electron. Example is in ammonia as well as in the water molecule. So the elements of 15 to 17 from the periodic table, they forms a electron rich hydrates and they behaves like a Lewis basis. Why it is behave like a Lewis basis? Because it can easily donate the electron to the other elements. Hence it is known as Lewis basis, or it is also known as electron donors. The presence of lone pair of electrons are highly electronegative atoms like the nitrogen, oxygen and fluorine hydrates results in hydrogen bond formation between the molecule. This results in association of molecule. This is how we can easily see that if electron-rich hydrates are formed by donating the lone pair of electron, whereas electron-precise hydrates, we have seen that it has a required quantity of electron to form a bond, that is a covalent bond. Similarly, electron-deficient hydrate, it has to require one more or two more electron to form a stable structure. Hence, it is also known as electron acceptor or Lewis acid. Now, let us see with the last one, that is metallic hydrate, or it is also known as interstitial hydrate. These are the hydrates of transition metal. So, we know that in our periodic table, from the group 3 to group 12, they are known as transition elements or D block elements. So, these are the hydrates of transition metal and inner transition elements. In transition elements, these are the small spaces occupied by the atom are known as intersites. So, when we look into the D block element, we know that in all these elements, if you consider any one of the element, usually it has some of the vacant spaces. Those vacant spaces, if it is occupied by the hydrogen, then you say it is molecular hydrate or interstitial hydrate. It is also known as what? Metallic hydrate or interstitial hydrate. So, the hydrogen gets absorbed into the empty spaces and to produce a non-metallic hydrate or interstitial hydrate. Hence, this is known as metallic hydrate. Remember, when we talk about the D block element, you can consider any one of the D block element. For example, titanium you can take, where in the titanium, the metal itself will consist of some of the empty spaces. We call that empty spaces as interstitial site. To that interstitial site, if hydrogen goes and occupies, then we say it is metallic hydrate. Okay. Example you can see with the zirconium hydrate, TaH and PrH2, titanium hydrate, lanthanum hydrate, YbH2, titanium H1, zirconium H1 and VH1 and nickel hydrate and palladium hydrate. So, the property of adsorption of hydrogen gas on the interstitial site, which is widely used in catalytic reduction or hydrogenation reaction for the preparation of large number of compound. Some of the metal can accommodate very large volume of hydrogen. Therefore, it is used in strong storage media, and this property has high potential of hydrogen storage. Hence, it is also known as storage or source of energy. Remember, just now we have understood that in the metal, especially the D block element, which is having some of the metals, in those metal, if interstitial sites are there, if it is goes and occupied by the hydrogen, we say it is metallic hydrate. If the metal which is having larger number of vacancies and it is occupied by the hydrogen, such metal hydrates are also known as sources of energy or storage of hydrogen. Why is it like that? Because those hydrate will be used in preparations of some of the important compound, and it is also used in catalytic reduction. So, hope you understood with the hydrates and their type. In the next session, we are going to talk more about the water and their structure. By this, I like to say that today I have covered the physical, chemical as well as the uses and the hydrates and the type. Have a look on it. Wherever you are not understanding, please pause the video and write the types, and it is very important for the examination point of view to know more about the hydrate for the competitive exam. Please have a look, make a note. We'll meet you with the next session. Till that, take care, be safe. Thank you.